This is a video lesson on drives, which are properties of functions and more generally properties of relations. So ways to describe a function or a relation. And this is the first part. We're going to talk about domain, range, and intercepts. But before that, just to talk a little bit about what that even means. This is a graph that shows the trajectory of a bird. It's called a kingfisher. It fishes. So it dives into the water, catches a fish, and it comes back up. And there are a bunch of different ways to talk about this graph and what it means, and to talk about different sections of it. So you can talk about, for instance, where the function is increasing, and I can highlight that part of the graph. So that's where the bird is on its way back up after it's caught a fish, or where it's decreasing, which is where it's diving. I can talk about where it's positive, which in this problem means where the bird is above the level of the water, and I can highlight that part of the graph as well. And there are a bunch of other things that you can say too. But in terms of the language and how to discuss that, there are specific properties, and the way that we list those properties or parts of the graph uses a special kind of notation. That's the mathematical language part of that. So where is this increasing? So I can highlight that part of the graph. But to give my answer, I list it in terms of the x values. And it increases from here, from 7 seconds all the way until 10 seconds, and the whole time in between. And the notation that we use for that is this square brackets. It started increasing at 7 seconds and it increased all the way to 10. How come 7's included and 10 is excluded? Well, we'll talk about that in a little bit. But that notation is called interval notation. And interval notation, like I just highlighted, tells you what points are included and which points are excluded by having the brackets either pointing towards or away from the number. So in a case like this, this increases from 2 to 7, and definitely 2 is excluded. How come 7 is excluded too? We'll talk about that in a minute. But that bracket facing away from the number means excluded. And we can use interval notation even to show if something continues forever. Like this function that starts here and goes all the way till infinity, I would say that this function increases from -5, this x value, all the way until positive infinity. And it's not positive because it's on its way up. It's positive because I'm listing the x values, and those x values continue towards the right all the way to positive infinity. So just very quickly, interval notation and how it works. If you want to pause for a minute and check each one of these to see if you're correct. This number line has numbers -4 to 3. I'm going to show the answers now. So if you want to check again, pause, see if you know how to write these. From -4 to 3, or -4 is excluded and 3 is included, it looks like this. From -2, included until infinity. This one, because it came from the left, starts at -infinity until 1, and this one from -3 till +1. Positive 1's included. Okay, so that interval notation, that's used to describe the different properties of functions. And these are the properties and a little bit about what they mean. And in this video, I'm just going to go through domain, range, and intercepts. Domain is the set of all x values that are part of the function. Every x value that exists is listed in the domain. It's listed from left to right, from smallest to largest. Usually, depending on the function, but most of the time using interval notation, because rarely will just a specific single x value be a part of the function. Usually it goes from somewhere all the way until something else. It's called continuous. Range is the same idea, but for the y values. You'll list them from smallest to largest, which graphically means from the bottom to the top. Intercepts are the values where the function crosses the x and y axes specifically. And then we'll talk variation extreme on sign in the next video. So domain is all the x's that are part of the function. In this case, my function seems to start right here. I'll start listing at this x value, and it continues up until here, or maybe here. It's tough to tell in this graph, so depending on how you read that graph. You might say 9, you might say 10. It looks to me like it ends here. And it goes from x equals 0 to x equals 9, and it goes that entire time. That is the domain, and it's listed this way. It started at 0, 0 was included, got all the way to 9, 9 is included. That's the domain. So in a case like this, my domain starts at 0, goes all the way to 60. That's the answer there. If there are units, I include them. If you want to pause for a second, try this one. That answer is from 0 to 350 kilometers, both included. Domain can also be figured out. So I'll show, if you want to pause for a second and try these, I'll highlight this one first. The domain is the set of all the x values. And here there are only 3 of them. There's -1, there's 2, and there's 4. That's the whole domain. Here, this first set represents the x values. 2, 3, and 7 are the domain. And in this case, where you have a function, the domain is any x that you could plug in, and I could plug in any x. So my domain is all real numbers. And range works similarly, except that regardless of whatever the x values were, the range is the y values that make up the function. And again, they're listed from smallest to largest, so from bottom to top. I'll start at the lowest possible y value, which here is 0. And it goes all the way up until a y value of 50. That's my range. And I write it in the proper notation. It goes from 0 to 50. Both of them are included in the function. So if you want to try these, you can pause for a second, check it out. The lowest y value here is -2. It goes up to a value of about 20, it looks like on this graph. So -2 to 20, I include units if they're there. That's my range. And here went from 0 to 30,000 meters. I included that in my units, but if I had written 0 to 30,000, that would have been correct as well. And the same idea here, range is all of the y values. So in this case, 3, 7, and 5. In this case, 1, 5, and 6. Sorry, just 1 and 5. 6 doesn't have an arrow pointing to it. And in this case, because if I plugged in any x values, I could eventually get any y value. Like to get -100, there's a specific x value. Or -1,000, there's a specific x value I could plug in. And that's range. And intercepts are where the function crosses the axes. So x-intercepts are where the function crosses the x-axis. That's all of these. And if this keeps going, potentially others as well. I would list those out. But because it's not the whole place between here and here, because it's just this point and this point and this point, you have to list them in set brackets, these squiggly brackets. So I list the specific values that are my intercepts. So here, where the function crosses the x and the y axes, the y-axis, which is also called the y-intercept or the initial value, is the place where the function crosses the y-axis. And there will only ever be one of them if it's a function. Otherwise, it wouldn't pass the vertical line test. So that's it for domain, range, and intercepts. And there will be another video on the other drive properties.